Right, we're going to do a similar problem mathematically to what we were doing with the cars and trucks problem, but just a slightly different context here. So we can kind of see how this works again in a different situation. So the Department of Streets of a city has a budget of $1,962,000 for resurfacing roads and hiring additional workers this year. The cost of resurfacing a mile of two-lane road is estimated at $82,800. The average starting salary of a worker in the department is $36,000 a year. Number one, write an equation that represents the relationship between the miles of two-lane roads the department could resurface, M, and the number of workers it could hire, P, if it spends the entire budget. All right, so similar to the last problem, let's kind of go back and just highlight some of the variables and what we're trying to calculate here. So we're told that it has a budget, a final budget of almost $2 million, $1,962,000. All right, and then we have miles of road that are getting resurfaced, and says each mile is estimated at $82,800. Okay, now I want you to notice down below here that the miles of two-lane roads is one of our variables. That's M. And then the other piece of information that we have up here is that average starting salary of a worker is $36,000 a year. And notice down below here, that's another variable. So the number of new workers it could hire, P. So number of new workers is the variable P. Okay. So similar to the last problem, we know that this is going to come out to a total budget of $1,962,000. And then each mile of road costs $82,800. So we got $82,800 per mile. Remember, miles was a variable that we had. Plus, our other number was the average starting salary. So each worker gets $36,000. And that was the other variable, P. All right, so between the miles that it costs to resurface the road and the amount that they have to pay for each one of the workers, we get a total budget then of $1,962,000. All right, so that's how we would interpret that situation in writing an equation. Again, this is kind of that standard form, general form equation where we have the variables on the same side of the equation. But what if we wanted to solve for P, the number of new workers? And so I guess we sort of previewed the answer here, but let's solve for P. So let's go ahead and go through similar to what we've done before. Let's rewrite our problem. All right, now let's go through our solving steps. And we want to solve for P, which means get P by itself. So let's get rid of the M, 82,800 M from both sides. So we'll undo. Since it's a positive, we're going to subtract it to cancel it out to 0. Bring down what's left. 36,000 P is equal to, remember, these are not like terms over on the other side. One has the variable M, one doesn't. So we're going to keep the 1,962,000 separate from the 82,000 minus 82,800 M. And then the second step is to undo the multiplication of 36,000 by dividing both sides by 36,000. And we get P is equal to, that would be 54.5 if we take 1,962,000 divided by 36,000. And 82,800 divided by 36,000 turns out to be minus 2.3 M. Okay, so now we've created an equivalent equation to the one up here. So these are equivalent. They have the same solution. We've just rearranged the letters to solve for P to get P by itself so that if we have the number of workers, we can plug that in. So I guess that was also one of the questions that was asked, is explain what this solution represents. All right, so let's talk about that for a sec here. So the solution is going to represent P right? We're solving for P, which is the amount of workers. So this equation's solution calculates the number of workers hired given the amount of miles. So the variable that we're plugging in here is the amount of miles to resurface. Given the amount of miles to resurface. Looks like we need a little bit more space on this problem, but we're just going to do the best we can with it. Okay. So P, which is the solution that we're trying to figure out here, we're trying to solve for P, and that's going to represent the number of workers that we can hire if we know the amount of miles. If we can plug the number of miles in here, then we can get the number of workers. Now the equivalent equation to this and the other one, so now we have a third equivalent equation, but that's already been done for us in this problem right here, is solved for M is M equals 23.7 minus 0.4 T. So now we've got all three equations here. What does this solution mean? Okay, so in this case, we've got M by itself. And so think about what M means in the problem. So we've got M equals 23.7. I'm just going to rewrite that here so we can see it a little bit more easily. So that's that equation there. So this equation's solution calculates, so M, remember, stands for the amount of miles of two-lane roads. So calculates the number of miles of road that can be resurfaced given an amount of workers hired. Because if you hire more workers, then you're paying more for the workers, and then you have a certain leftover for the amount of miles left. So the amount of workers that you hire would therefore impact the amount of miles that you could resurface. In reverse of that, in part A, the amount of workers that you could hire depends on the amount of miles that are resurfaced. So you can look at that either way, but in any case, it has to add up to the budget that we have of the $1,962,000. Okay, so then let's say that we have, the city is planning to hire 6 new workers and to use its entire budget. All right, so in this case, we're hiring the workers. So remember, we highlighted that in blue here. So 6 new workers are going to be hired. Which equation should be used to find out how many miles of two-lane roads that you need to resurface? So miles of two-lane roads, remember, was this equation right here, miles of two-lane roads, if we know 6 workers. So now we just need to put the workers amount in for T. So it's really that second equation that we're going to be using here. So the one that calculates the number of miles given the amount of workers. So let's use that equation, 23.7 minus 0.4 T, but now we know T, the number of workers, is 6, so we'll just put in 6 in for our equation. And I guess actually what I'm doing right now is finding the answer for B. So maybe we'll wait on that for just a second here. So I guess the first question was just asking us to think of which equation it would be, which would be that first one. Okay, so now let's go ahead and plug that in. If we've got 6 workers, let's plug that in and let's go ahead and calculate. Okay, if there were 6 workers that were all making that $36,000 salary, then how many miles could we actually go ahead and resurface? So let's Plug that in, 23.7 minus 0.4 times 6. And we come up with 21.3 miles. All right, so in each one of our problems, we had an original equation that we came up with, but then we needed to rearrange and solve for each one of the variables to create an equivalent equation that could more easily calculate the information that we were trying to find. So that oftentimes happens in things like science, like when you're doing formulas in science, density equals mass divided by volume. If you're solving for a mass, maybe you want to create the equation so it just has m by itself. If you're solving for the density, you have d by itself. If you're solving for the volume, you have v by itself. So it's easier to rearrange those formulas to solve for each variable to make the rest of the calculations easier.